Today's lesson is 10.3, the second one. We are continuing with our geometric sequences and series. 10.3, the first one was the sequences. Today we are looking at the series, which is the sum of the geometric sequence. You will need a calculator for this lesson. I am not going to be using one. I'm just going to be cheating. I do have a copy of my notes with the answers there already. So when we get to the problems that need a calculator, I'm just going to go with my paper and write the answer down. But again, we're looking at the sum of a geometric sequence known as a geometric series. The sum of the finite geometric series is given by this formula. Finite means it ends. So we're only looking at a certain number of terms. So the sum up through the nth term will equal A1, which is the first term, times 1 minus R, R being the common ratio, raised to that nth power, all divided by 1 minus R. That is your formula for the sum of a geometric series. So question number 1. Find the sum of the first 8 terms of this series. Well, you should recognize, for starters, that the first term in the sequence is 3. You should also recognize that the common ratio here is any term divided by the previous term. So -6 divided by 3 gets us -2. You might have also looked at 12 divided by -6, or you might do both just to confirm that it is actually geometric. But either way, our R is -2. And we want the sum of the first 8 terms, which means N is 8. And now just use the formula. So the sum of those first 8 terms will equal your first term times 1 minus, now the entire R is -2, to the nth power, which is 8, all divided by 1 minus that R. And just evaluate that. So 3 times 1 minus -2 to the 8th, 4 to the 4th, 16 squared, 256. 1 + 2 is 3. Now, in this case, 3's cancel, so it makes the math fairly easy. So we just simply get the 1 minus 256, which is a -255. And that is our answer. That's the sum of the first 8 terms. Again, it is simply it's another formula that you have to know. Got to have it memorized. But that is it. All right, next question. 2, find the sum. For I equals 1 to 12, 4 times 0.3 to the power of I minus 1. So, summation notation, this is a sum to begin with. I equals 1. So the first time through the loop, I is 1. So we get 4 times 0.3 to the 1 minus 1 power, or 0.3 to the 0th power, which is 1. So in other words, our first term here is just 4. Common ratio. Well, each one of these is going to be getting bigger as I is counting by multiple of 0.3. So R is the 0.3. And we're counting from 1 to 12. So that means N is 12. And once again, now just use your formula. So the sum of the first 12 terms will be 4. I probably should be writing the formula. Let's go ahead and write the formula first. A1 times 1 minus r. Now, since it is the 12th, I'll put 12 there, or 1 minus r. That's basically what we are doing. So that first term in this case is 4. 1 minus 0.3 to the 12th power. Now, I don't know off the top of my head what all that is. Reach for a calculator, and I just stuck the entire thing in the calculator. I didn't break it down into pieces. So what I've got is 5.714282677 is what the calculator told me. So I usually round to about 2 or 3 decimal places. Here I was rounding to 3 decimal places. If you're going on to calculus, you need to get in the habit of being in 3 decimal places. That's the way the AP test works. Next one. Similar fashion. Now, this time the summation is for n equals 16 to 31. So first time through the loop, n is 16. It's going to be 0.5 times 2 to the 16 minus 1. So 2 to the 15th power, and then times 0.5. Again, that would require a calculator. I'm cheating because I have the answer already. I'm not going to waste time in the video punching it out in the calculator. Now, each consecutive term here is going to be multiplied by a slightly higher power of 2, just counting by 1. So in other words, our common ratio will be 2. Now, how many terms do we have? Well, to find how many terms you have, you take the end minus the beginning, and that tells you how far you've gone. But we want to count that initial starting point of 16, so you do have to add 1 into that to count where you actually were when you started. So from 16 to 31 would actually be 16 terms. And then use your formula. So we want the sum of the first 16 terms. First term in this case, 16,384. 1 minus 2 to the 16th all over 1 minus 2. Again, reach for the calculator. Getting a really, really big number. Which if you don't have your calculator set at float 10, probably will give you something in scientific notation, which is not what we want. All right, but that's it. Pretty straightforward. Again, you just have to know the formula. All right, now that was for a finite geometric series. Now, as we flip the page to page 2, now we're going to look at the sum of an infinite geometric series. Now, I'm going to start with this note here at the bottom first. I'll start there. If that common ratio is bigger than 1, so like let's say it's 5. So each consecutive term is 5 times as big as the previous term. And you just keep getting bigger and bigger and bigger and bigger, and you go on infinitely, go on forever. That sum is just going to keep getting bigger and bigger and bigger and bigger, and it will not actually end. It's going to go to infinity, and infinity is not technically a number, it's a concept. So because it just keeps getting bigger and bigger, we do not have a sum. On the other hand, if that common ratio r is less than 1, and say the absolute value, so it could be positive or negative, but if that common ratio is less than 1, absolute value of it's less than 1, then it will actually approach an answer, and we will get an actual answer. And this is the formula. So, and it just says S, no subscript, because we're not doing the sum of the first 5 terms or 10 terms or 20 terms. We're just doing simply the sum. And it turns out to be a pre-simplified formula. Okay, it is simply A1, the first term, divided by 1 minus R. All right, so number 3, find the sum n equals 1 to infinity. Okay, again, first time through the loop, you let n be 1. We're going to get 4 times 0.6 to the power of 0, which simply tells us our first term in this case is 4. Common ratio is going to be the 0.6, and we don't need an n this time, it's infinite. So our sum is simply a1 over 1 minus r. So 4 over 1 minus 0.6. Goodness, excuse me. And this one I did not bother reaching for a calculator because 1 minus 0.6 is simply 0.4. Move all your decimals over one place, so basically you're just doing 40 divided by 4. So S is 10. I don't really need to waste my time pushing buttons for this one. A little bit easier. And it's an easier formula also. Okay, number 4. Now, part of the trick to this problem is recognizing that it is in fact a geometric sequence. The dot, dot, dot at the end tells us it goes on forever and ever. First term is clearly 3. Well, how did I get from 3 to 0.3? Again, you can take any term divided by the previous term to figure it out. But hopefully in this case, you just recognize you multiply by 0.1. And if you keep doing that, you get all the consecutive terms. So we do this forever and ever. So it is an infinite geometric sequence. Start with your formula. And again, here I'd move my decimals over one place, which basically makes it 30 over 9. And reduce the fraction. They're both divisible by 3. So your sum is 10/3. So we actually do get a sum for this infinite geometric series. All right, and now the last one. First term is 0.25. Again, take any term divided by the previous term to find your common ratio. Should recognize that R is -5 in this case. Again, we are talking about an infinite series, infinite sequence, but we're finding the series. But the fact that R equals -5, that's the key, because what that tells us is the absolute value of R is bigger than 1, which brings us back up here to this note. The series does not have a sum. It's going to just keep getting bigger and bigger, but it's not going to approach any value. So we would simply say no sum. And that is your lesson for geometric series. 10.3, the second one.